Welcome back to section 5. In this section, we are going to be looking at vectors in the plane. Now, this may look familiar to you. I know that we look at vectors in pre-calculus, and in another class, which I cannot think, Algebra 2 maybe. I know that I teach vectors in 2 different classes, so hopefully some of this looks familiar. If so, that's awesome. We're not doing calculus with vectors today, just looking at what is a vector. So, speaking of which, what is a vector? A vector is something with both magnitude and direction. Just like in Despicable Me, that character. He commits crimes with magnitude and direction. But what a vector is if we have 2 points, say point P and point Q, the vector is going to look kind of like that, where this one is going from P to Q. Now this vector would be written as PQ with a line segment over it with half of an arrow. It's not a full arrow because that would make it a ray. That ray keeps going. The vector has that definitive length. And so that's the idea behind a vector. A lot of times vectors, we can write them as PQ. We could also write them as vector U, vector V. It's usually a capital, or not a capital, lowercase, but bolded letter. So there are several ways of writing it. We'll see some of the ways. This specifically gets us into the starting point and the stopping point. And it does. The P is called the initial point, and the Q is called the terminal point because it's the start and the stop. We can multiply by scalars. So if you have, like, say, 2PQ, it would be the same thing, but it would be twice as long. Negative would be backwards. And so what we can do is we can write these in terms of U and V when we have U and V. So PQ, that would be just this distance right here. That's the same as U. So PQ is just U. QP, that would be going backwards. That would be negative U. QR, that'd be starting there and going all the way to R. That's going to be in the V direction, but it's not going to be one, it's going to be 2 of them. So that would be 2V. And then RS, starting there and going backwards. So this is, again, backwards. It's a U direction, but it's backwards. So it's negative U, and it's 3 U's long. So this would be negative 3U. And so starting out with vectors, like what is a vector? We'll get into how to deal with numbers in a couple slides, but it has a starting point and a stopping point. We can multiply by scalars, and that just changes the length and possibly the direction, like it could be negative. But that's the basics of vectors. We can add and subtract vectors. No, this wasn't supposed to be here yet, but there it is. Adding and subtracting vectors has a lot of real-world application. In fact, vectors themselves have a lot of real-world applications. In the text, there's a few of them. I'm not going to mention them here because that's just reading. But there's so many things. Flying, hey, you have the wind. So you're going in this direction, but the wind is pushing you in this direction, so really you're going in that direction. Same thing with water currents. if you have a river that's going that direction, and you're going to swim across, I'm going that way, swimming across at um, a certain speed, you end up going that way. You'd end up here. Even though you're just swimming straight across the river, it's pushing you downstream. So, how to add? There's a couple different ways of adding. There's the triangle method, where any way you add, you're going to put the tail on the head. So the tail would be the part without the arrow, the head's the part with an arrow. So the terminal point of the first vector becomes the initial point of the second vector. So we have u and then v, and then u plus v is the diagonal. We can use the um, parallelogram method as well, which gets exactly the same thing. It just does it slightly differently. It's the same. And honestly, when you're adding, you're probably not going to be using either of those because adding vectors is not particularly complicated. But understanding what the resultant vector is doing is important. A lot of times, making a drawing or understanding a drawing that comes with a problem, that's huge. And so, using these, we could write the following vectors using v and w, and there's v and there's w. So we want to go qp, or op. So o starts here, we're going to go 3 over. So we'll have a 3v plus 2w. O to q, that would be this distance. We'd again have the 3v, and then a negative w. So we'd have 3v minus w. And then qr, so starting at q, going to r, we'll have 1v and 2w. So those problems are not particularly difficult. They're not going to get much more difficult than that even. We're going to add some numbers to it. But this is the concept of what we're doing here. So components, the components of a vector, that would be the number part of it. So instead of just PQ, let's say we have the point P is 3, 7, and Q is 6, 11. And we have the vector that goes in between them, so PQ. We could write that in component form. Component form, it looks like an ordered pair, but it doesn't use parentheses, it uses these angled brackets. And it doesn't have x and y points in it, it has the change of x and the change of y. So, for PQ, in order to get from P to Q, x is going from 3 to 6, so it's going up 3. Y is going from 7 to 11, so it's going up 4. That's the component form of a vector. Oh. So this is just saying exactly what I said, only right underneath where I said it. So we have the head, we have the tail, we have standard position, which is also a position vector, and that just means that the tail, the initial point, is at the origin, 0, 0. Any other point could be anywhere. And then, so if we have this one right here in the middle is the position vector, because notice its initial point is at the origin. All of the rest are component vectors. They have the same magnitude and direction, but they're at different places. That's fine. They're called parallel vectors. A vector is a parallel vector if it is a scalar multiple of the other one. So if we have the one we had 3, 4, and we had 9, 12, well, 9, 12 is just 3, 4 times 3. And so that would be parallel. So we have our position vectors, and then we have the magnitude. Now the magnitude of our vector, we had the vector we came up with, PQ, was 3, 4. The magnitude of this vector is the length. Now if we drew this out, again, we had P and Q, and went over 3, up 4, and we had that. To find the magnitude is just the Pythagorean theorem. That's all it is. It's the distance formula. The notation for magnitude is going to be, it's going to look like absolute value, kind of like with matrices. So we have PQ, that's just going to equal the square root of 3 squared plus 4 squared, which we shouldn't need to do the math on that one. We should know that that will equal 5. So the magnitude is 5. Now we're going to see something called a unit vector in another slide or two, but there's two different types of unit vectors. One unit vector is a vector of length 1 in a certain direction. And so in order to find a unit vector in this direction, we would take the vector. So let's see, we have unit vector. It will be the vector PQ divided by the magnitude of PQ. So in our case, we have 3, 4 divided by 5, which is 3/5, 4/5. And that's going to be in the same exact direction. It'll overlap part of it, but the length of it will be 1. And so this is nice to know, because we could take this unit vector, it's a direction now, and we could multiply it by whatever length we would need it to be. So those are vector components. How to do operations with the component form. Adding and subtracting, you add the components. That's all it is. Let's say we have u equals 2, 7, v equals 3, -1, and we want to do things like, say, u plus v. We're going to add the x's, add the y's to get 5, 6. That's all it is. U minus v. Make sure we distribute that negative. 2 minus 3 is -1. 7 minus -1 is 8. 3u, we just distribute. So 3 times 2 is 6. 7 times 3 is 21. So that's all that these operations are. It's just adding the pieces, the like pieces together, multiplying. Those are pretty easy. So this is just the general rules for vector operations. Adding, we just add the two pieces. Subtracting, we subtract the two. And scalar multiple, we multiply each of them. A unit vector, so this is the other unit vector I was talking about. The unit vector, here we have the vector I and the vector j. Now the vector I is 1 unit horizontal. That one's I. The vector j is 1 unit vertically. And so we could take this vector that we had, 3, 4, and we could write this using the unit vectors. This could equal 3i plus 4j. Why would that be important? There are things where having it split up into the component forms makes it a lot easier. Sometimes not, but we can go back and forth between those two things. Um, and then properties of vectors, there's just a bunch of properties of vectors. Generally speaking, if you think that you should be able to do it, you probably can. Unless it's obviously stupid, then don't do that. Um, I mean, it's commutative, they're associative. There's a zero vector that would be notated as 0, and it is a vector. It has a magnitude of 0, so there's no length, and it has no direction either, really, because the length is 0, so there's not really any direction. Um, But yeah, so those are properties. There are some applications in the section. There's a few other little pieces here and there, but this is a pretty easy topic. We don't need to go very long on this one. We had the last one that we went really long. So, but I would take a look at the applications. It's just using a formula. It's pretty straightforward. Um, and then work problems. Keep working problems. Keep asking questions. And as always, happy mathing.